Hey guys, it's Ms. Masso. We're going to do our Chapter 6 study guide over polygons. And just a quick apology if I do cough during this. I still have a little bit of a tickle in my throat, so just be prepared in case that happens. So let's get ourselves started. Number 1, if measure of angle B is equal to measure of angle D, and they're both 39 degrees, find the measure of angle C so that quadrilateral ABCD is a parallelogram. The diagram is not to scale. Now, I'm going to go through, I'm going to mark in angle B and angle D, both being 39 degrees, and they're the same, so I'm going to put one arc mark on both. And now remember, in a parallelogram, the top and the bottom segments are parallel, as are the left and the right segments as well. In a parallelogram, the angles that are opposite each other or diagonal are congruent. So angle A and angle C are also the same. Now, I also know, I'm going to zoom in a little bit here, that in a parallelogram, if you add up two angles that are on the same line right here, on the same parallel line, angle D and angle C, you should get 180 degrees. So if I already have 39 of the 180, to figure out what angle C is, I'm going to take 180 and I'm going to subtract 39. So 180 minus 39 gives me 141. So the measure of angle C is 141 degrees. So angle C is 141. And because this is a parallelogram, angle A is also 141. If I were to add up all of these angles together, because it's a four-sided figure, I should get 360 degrees. So it's a great way to check my work in case I wasn't sure. Number 2. Find the values of the variables in the parallelogram. The diagram is not to scale. Again, a parallelogram means that angles that are opposite each other or diagonal from each other should be congruent. So I already see that angle 102 right here is diagonal from angle Z. These two should be congruent. So since this is 102 degrees, angle Z is also 102 degrees. Right, and that's because angles that are opposite angles are congruent in a parallelogram. So that's my first one, angle Z, easy peasy. Second one, I see that I'm given this 29 degrees right here. Now, I've got two parallel lines cut by a transversal. If I go opposite of this 29 over here at angle X, these two are considered alternate interior angles, and I know that alternate interior angles are congruent. So since this is 29, angle X is also 29 degrees. So angle X is 29 degrees because alternate interior angles are congruent, and that's what we have right there. My last one is this angle Y right here. Now, although it also is considered an alternate interior angle, but I know that if I go over here, well, unfortunately, I have nothing over here. So I know these are congruent, but that doesn't really help me because, excuse me, there's nothing over here. However, if you look at the right side here, you will notice that in this parallelogram, this diagonal cuts my parallelogram into two triangles. I know that a triangle has 180 degrees. I already have 29 and 102 of the 180. So to figure out my angle Y, I'm going to take 180 and I'm going to subtract the 102 and 29. That'll give me what's left over for angle Y. So I'm going to do 180 minus 102 plus 29, right? So I'm going to add these two together and then subtract them from 180. So when I do that, these two added together gives me 131. So 180 minus 131 gives me 49 degrees. So angle Y is 49 degrees. And I know that because, right, in a triangle, all of my angles add up to be 180 degrees. So you have to use a little bit of deductive reasoning here to get your answer. Number 3, find values of X and Y for which this must be a parallelogram. The diagram's not to scale. Now, in a parallelogram, I know again, I've got parallel lines, so I'm gonna mark those. I also know that these pieces here, AC and DB, are diagonals. In a parallelogram, diagonals bisect each other. And bisect means cut in half. So if I'm taking something and cutting it in half, that means the two pieces that are left over should be congruent. So, excuse me, I have this piece right here, AC. This is one diagonal. The two pieces of AC should be congruent. So because these are the same, I'm just going to set them equal. I'm going to do 3x minus 10 equals x plus 8. And then it's a quick algebra problem. So I get all my x's to the same side by subtracting x. 3x minus x gives me 2x. Bring down my minus 10 and my 8. Next thing is bring my numbers to the other side to get my x alone. So I add 10 to both sides. I get 2x equals 18. And my last step is to divide both sides by 2. And I get x equals 9. So there's my first variable. Again, same idea because it's a parallelogram. I now have another pair of diagonals, and so these two should be congruent. So this piece here, D to the center, and then the center to B should be congruent. So again, because they're congruent, I'll set them equal. 6y minus 8 equals y plus 7. So again, it's just some quick algebra. Subtract y on both sides, get all my y's together. I get 5y minus 8 equals 7. I add 8 on both sides. I get 5y equals 15. And then I divide both sides by 5. So I get y equals 3. So again, the important part here is that diagonals bisect each other in a parallelogram, so I set my equations equal. Number 4. Now, I'm given a couple of different lengths with different equations. I'm going to just copy these equations onto my picture here. So ON is 5x minus 4. LM is 4x plus 7. NM is x minus 7. And OL is 2y minus 6. Now, this is a parallelogram. Because of that, I've got my sides that are parallel and are also congruent. So at the top and at the bottom, they're parallel and congruent. On the left and on the right, they're parallel and congruent. When things are congruent, we just set them equal. So I'm going to start over here with these two at the top and the bottom, because if I tried to do these two on the left and the right, one's got a y, one's got an x. It's going to be really hard for me to do that problem with two different variables. So I'm going to start with the one that has one variable. So I'm going to do 5x minus 4 equals 4x plus 7. And we'll start with the x's. So I'll subtract 4x on both sides to get all my x's together. 5x minus 4x gives me 1x, so I'm just going to put an x. Minus 4 equals 7. And then to get the x by itself, I add 4 to both sides. So I get x equals 11. Should have brain fart there. X equals 11. Okay, now I already have my x variable, which is great, but I still need to figure out my y variable. Now, if I tried to set 2y minus 6 equal to x minus 7, that's not going to work out. Again, because like I said, two different variables doesn't work for me. However, I already know the answer to the x. X is 11. So I'm going to take that 11 and I'm going to substitute it in for x. So 11 minus 7 is the length of this side, which gives me 4, right? So 11 minus 7 means this side, NM, is really 4. It's equal to 4. That means this side over here, OL, is also equal to 4. So in order to figure out the y, I'm going to take 2y minus 6 and set it equal to 4. And that's how I'm going to solve for the y. Now again, just some quick algebra. Add 6 to both sides. I get 2y equals 10. and then divide by 2. I got y equals 5. So my final answer is x is 11 and y is 5. So you did have to do a little bit of substitution for that problem. Number 5. Below is a rhombus. It tells me angle 1 is 3x, 2 is x plus y, and 3 is 30z. Find the value of each variable. The diagram is not to scale. Now, in a rhombus, everything on the inside, all of these angles, are equal to 90. So essentially, I'm just going to set each equation equal to 90. So here's angle 1. Angle 1 is just 3x. So I'm going to take 3x and set it equal to 90. So it's one super quick problem, right? I just divide both sides by 3. So angle 1 equals, or sorry, not angle 1, x, excuse me, x equals 30 degrees. There's my first angle, angle 1, done. Angle 2, again, should be 90 degrees. Now, angle 2 has the equation x plus y, and I'm going to set it equal to 90. Now, just like in my last problem, I've got a little bit of an issue, right? Because I've got an x and a y, and I've got no numbers. I'm going, what the heck do I do now? But you already figured out angle x. You already figured out what it is. X is 30. So I'm going to take that 30. I'm going to plug it in or substitute it where I see the x. So 30 plus y equals 90. Now it's one step to get the y by itself. I'm going to subtract 30 from both sides. I get y equals 60 degrees. Okay, there's my second one. And now my last one, angle 3. For angle 3, it just says 30z. So I'm going to take 30z and just set it equal to 90. And to solve for z, I just divide both sides by 30. I get z equals 3 degrees. So just like in the last problem, I did have to use an answer to substitute it in, but since it's a rhombus, all of the angles always are 90 degrees on the inside. Okay. Number 6. Excuse me. DEFG is a rectangle. I give you some of the sides, and then I say find the value of x and the length of each diagonal. Now, I don't have a picture, so anytime you're not given a picture, I always suggest drawing one because otherwise, how would you know what to do? DEFG. Doesn't matter where you start. All that matters is you go around in a circle when you name them. Now, DF is 5x minus 3. So from D to F, it's 5x minus 3. The other one I give you is from E to G. That's this one. This is x plus 21. Now, I know in a rectangle is a type of parallelogram. Because of that, my diagonals bisect each other, so they are congruent. They're exactly the same. So all I'm going to do is take my two equations and set them equal. So my diagonals are congruent. All right, so I'm just going to take the two equations, set them equal. X plus 21 equals 5x minus 3. Then it's quick algebra. So I want to get all my x's together, so I'm going to take this one x by itself and subtract it. I get 21 equals 4x minus 3. I'm going to add 3 to both sides. I get 24 equals 4x. And then the last step is to divide by 4 on both sides. So 24 divided by 4 gives me 6. So my x value is 6. Now, the other part of the question says, find the length of each diagonal. So this is a diagonal and this is a diagonal. I need to take my answer and I need to plug it in. It doesn't matter which one you plug it into because I should get the same answer regardless. So because of that, I'm just gonna plug it into the easier one. Hello. This one right here is way easier, so I'm just gonna plug it in. So x plus 21, instead of x, I'm gonna plug in a 6. So 6 plus 21, each of my diagonals is equal to 27. So you do have to take your answer and plug it in when you're finished. Number 7. LM is the mid-segment of trapezoid ABCD. And then I give you some lengths. So let's mark down the lengths that we have. AB is x plus 8. LM is 4x plus 3. DC is 201. Okay. So if we remember the formula for the mid-segment, it's base 1 plus base 2 divided by 2 equals the mid-segment. Now the mid-segment is this piece right here in the middle. My base 1 and base 2 are the parallel lines at the top and the bottom. So I'm going to name the top one B1 and the bottom one, B2. Doesn't matter which order I put them in, as long as the mid one is in the center. So now I'm just going to plug them into the equation. Base 1 is x plus 8 plus base 2 is 201 divided by 2 gives me my mid-segment, which is 4x plus 3. Okay, first thing I'm going to do is I'm going to just combine some like terms. So at the top I can do 8 plus 201, which gives me 209. I'm just rewriting everything else. Now from here you have two choices. Now there's no number in front of the x, you can put a 1 there. If you want, you can divide each of these numbers by 2, and that's fine, you can do that. Or if you don't want to divide by 2, you can also multiply by this 2 on both sides. So you have two choices. You do whichever one you prefer. I like to multiply, so I'm going to multiply mine. Multiply this whole thing on the left by 2, multiply the whole thing on the right by 2. These 2's will cancel. I'm left with just x plus 209 equals, and now on the right side, I need to distribute this 2 to everything on the inside. So 4x times 2 gives me 8x, 3 times 2 gives me 6. So now here's the equation I'm going to solve. Okay, I kind of ran out of room, so I'm going to rewrite it so I have enough room. All right, to get my x by itself, I'm going to move this x that's all alone over here over to the other side by subtracting it. So I get 209 equals 7x plus 6. Now I'm going to subtract 6 from both sides. I get 203 equals 7x, and then divide both sides by 7. So 203 divided by 7 gives me 29 is my x value. So if you didn't want to multiply by 2, you could have divided by 2. You just would have gotten a decimal right here, but eventually the decimal would have gone away, and you should still end up with 29 even if you decided to divide instead of multiply like Ms. DeMassa did. Okay, number 8. Angle B and angle S are base angles of the isosceles trapezoid bucks. If measure of angle B and S are given, find the measure of angle U. Now, I'm going to draw myself a quick sketch. Here's my trapezoid. It says B and S are at the bottom. So here's B, here's S. That means U and C are up above. Excuse me. I give you angle B and I give you angle S. Now, because they're both on the same parallel line, these two are congruent. And because they are congruent, I'm just going to set my two equations equal to each other. So I'm going to do 22x plus 7 equals 14x plus 15. I'm going to solve for x. I'm going to write really tiny because there's not a lot of space. So I'm going to subtract 14x from both sides. To get all my x's together, I get 8x plus 7 equals 15. Then I'm going to subtract the 7 from both sides. I get 8x equals 8. And then my last step is to divide both sides by 8. So I get x equals 1. Now, that's great, but the question asks me to find the measure of angle U. Okay. So, excuse me. I know these two angles down at the bottom, right? They're given to me. So what I'm going to do is I'm going to take this 1 and I'm going to plug it into one of these equations. Now it doesn't matter which equation I plug it into, I should still get the same answer. So I'm going to plug it into this one. This one's a little simpler, angle S. So angle S is 14x plus 15. So instead of the x, I'm going to put a 1. So 14 times 1 is 14. 14 plus 15 gives me 29 degrees. So I know these two angles are both 29 degrees. Now, to figure out what angle U or angle C are, they're both the same as well. I know that two angles that are on the same leg of a trapezoid should add up to be 180. So to figure out this angle, I'm going to take, so to find angle U, I'm going to take 180 and I'm going to subtract the 29 and that'll tell me what's left over. So if I subtract 180 minus 29, I get 151. So my final answer, is 151 degrees. So angle U and angle C are both 151 degrees. Number 9, find the sum of the interior angles of a 13gon. Now, remember, to find the sum of the interior angles, I take the number of sides minus 2, and then multiply that times 180, and that should give me my answer. So, number of sides in a 13gon is 13 sides. That's why we call it that. So, 13 minus 2, and then I multiply that times 180. Okay, so 13 minus 2 gives me 11, and 11 times 180 gives me 1,980 degrees. And that's it. I know that one was an old one, so you gotta kind of like think back to remember that one. Number 10, find the measure of one interior angle of a regular 15gon. So first I have to figure out what's the total number in a 15gon, and then to find out the individual amount for each one, I'm just gonna divide by the number of sides, which is 15. So I'm going to do the same thing I did up here, n minus 2 times 180. So 15 minus 2 gives me 13, and 13 times 180 gives me 2,340. Now, that's the total amount of all of the interior angles. To figure out just one, I'm going to take that total amount and I'm going to divide it by the number of sides, which is 15. So 2,340 divided by 15 gives me 156 degrees. So each angle, each interior angle, interior is important, of a regular 15gon is 156 degrees. Number 11, find the measure of one, again, exterior angle of an 18gon. All right, so this one's a little different. I'm talking about the outside, not the inside. I'm still gonna do the same steps. And this is gonna give me my interior. still going to do the same thing. N minus 2 times 180. So I've got 18 sides minus 2 times 180. So 16 times 180 gives me 2,880. Again, that's my total interior. To figure out one individual interior, I'm going to take that total and divide by the number of sides, which is 18. Again, that's number of sides. Okay, so each interior angle when I divide these two numbers is 160 degrees. So that is for each or for one interior angle. Now, that's great, but I want to know exterior. So now, my interior angles, imagine you've got some kind of like 20-sided, whatever. Okay, wow, that was terrible. Got some kind of polygon, an 18-sided polygon. On the interior here, it's 160 degrees. To figure out the exterior, I need to know this angle on the outside. Well, this should make, so here's this is like the inside. This is a terrible picture, but the inside is 160 degrees in here. I want to figure out what the exterior is out here. I know though that it should make a straight line, and a straight line is 180 degrees. So to find the exterior of just one angle, I'm going to take 180, a straight line, and subtract 160. So one exterior angle is equal to 20 degrees. So there's a lot of work to get there, but in the end, we got it. Okay, almost done. Number 12. The measure of the interior angles of a hexagon are all these equations. Find the value of x. Now, interior, again, the equation for interior in total is n minus 2 times 180. So hexagon has 6 sides. 6 minus 2 is 4, and 4 times 180 is 720. So all of my interior angles, this is my total, should add up to be 720. Now, I've got all these individual angles in the hexagon. I'm going to add all of these angles together and set them equal to 720. So it's going to be a very long equation. 2x plus 3x minus 2 plus 3x plus 7 plus x plus 5 plus 6x minus 1 plus, excuse me, 4x plus 8 equals, 720 degrees. Oh my gosh, so much to do there. But it's just an algebra problem. I'm just going to combine some like terms together. So I'm going to put all my x's together. 2x, 3x, 3x, x, 6x, 4x. Oh my gosh. Okay. 10, 11, 12, 13, 14, 15, 17, 18, 19 x's in total. Now I'm going to put all of my numbers together. -2 and 7 is 5. 5 and 5 is 10. 10 and -1 is 9. And 9 plus 8 is 17. Woo! And then I set it equal to 720. Oh my goodness, so much work there. Okay, now it's easy. Get my x's by themselves, so I'm going to subtract the 17 from both sides. I get 19x equals 703. And then divide both sides by 19. I get x equals 37, and we're talking about angles, so it is degrees. Excuse me. Last one, number 13. For the pentagon below, I give you angle 1, 2, 3, 4, and 5. Now, notice these angles are all on the exterior. That's important because no matter what shape it is, the exterior angles should always add up to be 360 degrees, a circle, excuse me. So I think I played that little meme for you guys where it showed you when all of these different shapes came together, they made a circle. So in total, all of my numbers should add up to be 360. So anytime you see exterior, you're gonna set it equal to 360. So just like the last problem, I'm gonna add together all of my angles, and then I'm gonna set them equal to 360. Okay, so x plus 7 plus 4x minus 2 plus 3x plus 4x plus 9 plus 3x plus 1 equals 360. Okay, now I'm just going to combine some of my terms like I did before. 4x gives me 5x, plus 3x gives me 8x, plus 4x gives me 12x, plus 3x gives me 15x's. Okay, now I put my numbers together. So let's do 7 and negative 2 gives me 5. 5 and 9 gives me 14, plus 1 gives me 15. And I set it equal to 360. Okay, now the x's are already by themselves on the left, so I'm going to move the 15 to the right by subtracting it because it was positive. 15x equals 345, excuse me. And then divide both sides by 15 and get x equals 23 degrees. All right, so hope that helped you guys out with your chapter 6. If you need any other additional help, let me know. These will be posted, this answer key will be posted in the classroom on the board. Hope it helped you out, and good luck on your chapter 6 test. Have a grand day.